is equal to x squared plus 2x minus 3. So let's find a few things. We'll find the vertex. Let's find the axis of symmetry. And let's put C over here. Let's find the intercepts. So I'll get. All right. So remember, when you're trying to find the vertex, you're trying to find HK, right? And so we know H is negative B over 2A. And so in that case, or in this case, it's going to be negative 2 over 2 times 1, which would be negative 1. And so that's going to be the x value of our vertex. To find the k value, we're just going to plug in that h into f, find out what's the correlating quantity. And so this is going to be negative 1 squared plus 2 times negative 1 minus 3, which is going to be 1 minus 2 minus 3, between negative 4. So my vertex is going to be the point negative 1 comma negative 4. Don't forget to close it. Any questions on that? Here or there? Nope. All right, so to find the axis of symmetry, remember that's just the vertical line that bisects the parabola. Is the vertical line that passes through the vertex. So we know it's going to be written as x is equal to h. And so in this case, it's going to be x is equal to negative 1. Like I said before, don't forget that x is equal to. In my math lab, they may give it to you. I'm supposed to go check that. I totally forgot. They may give you the x is equal to and just put a blank. But if not, make sure you write x is equal to. Any questions on B? And C, our intercepts. Well, remember we got two types of intercepts. Don't forget about any of them. We have y-intercepts and we have x-intercepts. I'll be doing y-intercepts first. For these, they're the easiest. So remember, for y-intercept, we're going to set the x to 0. And if we do that, we'll have y is equal to 0 squared plus 2 times 0 minus 3, which means that y is equal. Oh, sorry, negative 3. The other way you can do the y-intercept, if you recall, is it is just the c value. Whatever c is, that's going to be your y-intercept. So it's going to be 0 comma negative 3. Questions on the y-intercept? How about x-intercept? So we can determine if we're going to have an x-intercept first. If my vertex is negative 1, negative 4, that means it's below the x-axis. And it opens upward because the a value is a 1 right there, it's positive. So we should have 2 intercepts. Okay. If the y value for the vertex is 0, then you have 1 intercept. If the vertex is above the x-axis and it opens up, you're going to have none. If the vertex is below the x-axis and it opens down, you're going to have none. So you can use that as a little clue to help you out before you get started. So we're going to say, well, we're going to set y equal to 0. So x squared plus 2x minus 3 is equal to 0. And try to solve that for x. This one, we can factor. Right, AC, if we go that route, is negative 3. B is a positive 2. Things that multiply to be negative 3 and add to be positive 2. A negative 1 and a positive 3 will do it. And so this will factor to be x minus 1 times x plus 3. Is equal to 0, which means x minus 1 is equal to 0. X plus 3 is equal to 0, which means x can equal 1 or negative 3. So we'll have two x-intercepts like we thought. It's going to be 1 comma 0 and negative 3 comma 0. And those are my intercepts there. I think on my math lab they're going to ask those separately. They're going to ask, what is the y-intercept? What is the x-intercept? And I recall, because I was looking at the problems a little while ago, they did say, like, there was an option to say there is no y-intercept, but there should always be a y-intercept. So don't get confused by that. X-intercept, there may not be an x-intercept. You just got to do your due diligence to see if there is or not. I'm looking up for that equation of the axis of symmetry. Okay, they do not put the x equals for you, so you need to make sure you type that. It even says type an equation in the directions. So for the axis of symmetry, make sure that you type in the x is equal to. I forgot I had a copy of the study guide with me, which has questions from the homework. So check. Any questions on that one? Good here. All right. Good deal. We're going to skip through this. I don't think we need to do any more. Those we can come back to if we got time. Oh, that's what it was. I skipped the notes. We had more problems yesterday. I was like, where are the notes? Here we go. So, maybe. There we go. So, if you recall, we were talking about linear functions. In order to find out what the equation of the function is, just like a line, we need either 2 points or the slope in a point, the rate of change in a point. So that is what we need for a linear function. For quadratic, it's a bit different. We still only need 2 points, but we need or at least one specific point. And if you think about what a parabola looks like, one of the main things about it is, what is that vertex? What is the vertex, right? And so if we know the vertex and we know another point, any other point on that parabola, we can find out what the equation of that quadratic function is. I just mixed up every word in word. So if we have the vertex and a single point, doesn't matter what the point is, we can find the equation of that quadratic. And the way that we can do it is by using this form right here. So this is another form that a quadratic function can be written in. Remember the other form that we learned yesterday was f of x is equal to ax squared plus bx plus c. These variables here are the same ones. It's still the same x. But what changes is the k is going to combine with some other stuff to give us the c. That a is still the same a though. The h, that's from the vertex. The h and the k are from the vertex. So we have f of x is equal to a times x minus h squared plus k. What people tend to mess up the most here is this x minus h squared plus k. And I've done it before myself too. I put minus k. Don't do minus k. Plus k. And so the concept about finding the quadratic function from these values and using this form, it can be a little bit confusing, but let's talk about it first, and then we'll try an example. And if you have questions after that, let me know. So when we're looking at this and we think about what we have, if they give us an HK, they give us the vertex, and they give us some other point, then that means they're giving us HK, and they're giving us an X and Y to go together. That's the two things that they are providing. And if we look at our formula, I don't want to say form, our form here, not form, our form of the function here, the only thing we do not have is A. And so what we're going to do is plug in the H, plug in the K, plug in the X for the X right there, and plug in the Y for F of X. That way the only variable there is A. If we have an equation with one variable, we can solve for that variable. And that's what we're going to do. We're going to solve for A, and then we're going to find the equation of our quadratic function. Any questions on that? Let's give it a shot. So, I had this on the screen earlier, but we want to determine the quadratic function whose vertex is 1, -5, and whose y-intercept is -3. So remember, what do we need? What do we need to find the equation of a quadratic function? I need the vertex, which I have. Oh, I want to blue. There we go. There's my vertex there. And I need a point. Do I have another point? The y-intercept, yes, good. And so the y-intercept being -3 means that I have the point 0, -3 as well. So now, oh, won't that work? There we go. Let's move this over here. So now I have all that I should need. I have a point, I have a vertex. So that means that I know H is 1, K is -5, and an XY pair, X is 0, Y is -3. Any questions on that? All right, let's see how we're going to use it. So we're going to be utilizing that form of f of x is equal to a times x minus h squared plus k. And we're going to substitute what we know. Okay, we know that x is 0, h is 1, k -5. What is f of x? It's -3 is the y value. Remember that your y value is the same thing as f of x, right? Good job. So we're going to plug all that in. All that should remain is the a, and we're going to find out what that a is. So we're going to have -3 equal to a times 0 minus 1 squared plus a -5. Be careful with your simplification here, your evaluation. Be careful with your evaluation of what's going on. And what I mean by that is, okay, left-hand side, that's not bad, it's -3. The right-hand side, we're going to have 0 minus 1. That's going to be a -1 squared, and let's make this -5. And the thing that normally gets people here is when they square that -1. If you're going to do it in your calculator, I know 1's not a hard one, but what if it was like 2, -2? Or -3 or something. and you do it in your calculator, you want to make sure you put parentheses around it, okay? Because there's a difference between just -1 squared or -1 in parentheses squared. The calculator is going to treat it different. So a -1 squared is just 1, so we end up with a times 1 minus 5. So a -3 is equal to a minus 5. Any questions so far on that? Solve for a. I'm going to add 5 to both sides, get my a isolated. And we're going to have 2 is equal to a. Any questions on that? Good. All right. So what we want to end up with is f of x is equal to ax squared plus bx plus c. I want to end up with that normal. Man, that really messed up. Let me do it again. Sorry about that. I had to write too fast. There we go. We want to get in that normal quadratic function format that we talked about yesterday. That's what we want to do. Now notice, in that form, the f of x and the x's stay there. They don't have values in them. And the way that we're going to achieve that is by only substituting in the a, the h, and the k. So we're going to go back to this right here, but we're only going to substitute in the a, the h, and the k. We're going to leave the x and the f of x alone. We're going to let those be general variables. And so what we're going to end up with, let's go with red one, is f of x is equal to 2 times x minus 1 squared plus a -5. So we're substituting everything but x and f of x. Substituting in a, substituting in h, substituting in k. And then we're going to evaluate it a bit. We want to get it to ax squared plus bx plus c. Right now it's not. So I'm going to square the x minus 1. You want to write it out and use FOIL or whatever on the side. So it's going to be x squared minus 2x plus 1. And let's switch that to minus 5. Big alert here. Make sure that you keep this grouped in parentheses because the 2 is still going to be multiplied through that. It's going to distribute through that. That's another common error that messes up, that people mess up with. Yeah. And so we're going to distribute that too. 2 to the x squared, or 2 times x squared is going to be 2x squared. 2 times the negative 2x would be negative 4x. 2 times a positive 1 would be positive 2. And we got a minus 5. And so now I have ax squared plus bx plus, not c yet, but we'll do 2 minus 5. And that is negative 3. That's our quadratic function. Cool little thing to check your work. If they gave you the y-intercept, hey, check it against your c value. They said the y-intercept was negative 3. I got a c value of negative 3. That's good to go. So you can use that. It's kind of a little check. It's not gonna check everything. If you want to check everything, plug in the h and k values for x and y. See if they equal out. Plug in the other point they give you too. See if it works out. But a quick check, if they give you the y-intercept, your c value should be that same value. Any questions on that? historically, this has been a hard topic for students. So we're going to do a lot of examples. Get through it. So if you do have questions, let me know. Don't stay confused. And I think practice is kind of the key to understanding this somewhat. So let's start here. So this is how the homework's going to be, I think, as far as I saw. They're going to give you a graph, and they're going to want you to find the quadratic functions equation. But the graph does contain the vertex and another point. This one is also the y-intercept, it looks like. So give this one a shot. Or, well, once again, they give us vertex. You have to have the vertex, otherwise you don't know what the function is going. And one other point. And so we got a vertex of 2, -6, so h is 2, k is -6, and then they give us the point of 0, -2, which is the y-intercept, where x is 0, y is negative, or f of x, right? And so we're going to plug all that in. We're going to say -2 is equal to a times 0 minus 2 squared plus -6. So we have -2 is going to equal what? 4a minus 6, right? Because the negative, so 0 minus 2 is going to be -2. Get squared, it's going to be +4. And we're going to add 6 to both sides. So this works out really well. And we'll get 4 is equal to 4a. Divided by 4. A is equal to 1. If you get an a is equal to 1, it's a beautiful thing. Now, there is kind of a check you can do for your a value. If they give you the graph, this graph opens up. If I got a -8, something went wrong, right? Just remember, for the graph to open up, a needs to be positive. That's the same 8 that we're talking about. We didn't change any letters or anything. It's the same 8. So you can kind of use that to check your a little bit. Say, oh, wait, doesn't match my graph. Sure, try it again. But if it does match, hey, we're good to go. Any questions up till that point? So now we're going to plug everything back in, but the f of x and the y, we're going to plug into a, plug into h, plug into k. And we're going to have what? F of x is going to equal 1 times, x minus 2 squared minus 6 plus -6. So I'll just write it as -6. So we're going to expand that term that's squared. We're going to say f of x is equal 1 times x squared minus 4x plus 4. And we still have the -6. If you need some help expanding those, let me know. We could do a little tutoring session outside of class, get you caught up with that. Yeah, f of x, let's distribute that 1, which that's the multiplicative identity, so it's not going to change anything. So we're going to have x squared minus 4x plus 4 minus 6. That's what's nice about having when your a is 1. And then to get our c term, which should be -2, we're going to add the 2. Add the 4 and the -6, which looks like it's going to work out. There's our quadratic equation. I'm going to fix this up. There we go. Any questions on that one? I got it. Oh, you can't see. I got it. All right. A few more of these. So they like to give you the y-intercept. I'm not really sure why. I guess it makes it easier, honestly. So try this one out. You got a vertex of -2, 5. Oh, that's true. I do need to talk about that. I'll think about it and let you know. Let me think about it while during class. You got a vertex, -2, 5, and you got a y-intercept of 0, 1. And so try to find the equation of this one. Notice that it opens down, so a should be negative. All right, so I like this one for a few reasons. We'll talk about it as we get through it. So our vertex has a h value of -2, our k value is 5 from that vertex, and they give us an x and a y. Remember, that's f of x, same thing as y. Looks like another y-intercept, 0, 1. Always nice. We should get a c value of 1. We should also know that a should be negative because it opens down, so we can utilize that to help us with our final answer. So let's plug everything we know into f of x is equal to a times x minus h squared plus k. So that's going to be 1 is equal to a times 0, and it's going to be minus a -2 squared plus 5. So notice inside the square, so it's 0 minus a -2. That means it's going to be 0 plus 2. Where 1 is equal to a times 0 plus 2 squared plus 5, which is going to be a times 2 squared, which would be 1 is equal to a times 4 plus 5. And if we want to solve, we're going to subtract 5 from both sides. So we have -4 is equal to 4a. Divide both sides by 4, and we get a is equal to -1. Supports the idea that it opens down. We're good there. Any questions so far on that? So remember, we're going to plug everything back in, everything but the f of x and the x. So we're plugging a, plugging h, plugging k. So we're going to have f of x is equal to -1 times x minus a -2 squared plus 5. Be careful here because now the minus a -2 really matters. You're going to make that plus 2. And so we'll have f of x is equal to -1 times x plus 2 squared plus 5. And let's square that out. So if we expand that, it's going to be -1 times x squared plus 4x plus 4 plus 5. Now this is where most of the mistakes happen. This -1 is going to distribute. It's going to go to x squared. It's going to go to 4x. It's also going to go to 4. So what you end up with is f of x is equal to -x squared minus 4x minus 4 plus 5. And then the last thing we got to do the arithmetic on those constants on the end to get my c value. However, f of x is equal to -x squared minus 4x plus 1, which that goes along with the y-intercept they gave us. Any questions on that problem? No? Good. So, who was it that asked that? Nigel, you asked about the quiz. I decided not to do a quiz for 4-1, 4-3, 4-5, just so you don't have a ton of work swamped on you. So make sure you use the homework to study for the test. There's also the study guide, so you can see what types of problems I'm planning on putting on. So I just didn't want to give y'all more stuff to do, especially because we're kind of, it feels like we're going fast. We use 4-1, 4-3, 4-5. I guess they're not very long. Okay. Oh, sorry about that. Let's get that back. There we go. What we got? 2 more. All right, y'all try this one. This one doesn't have a graph. This gives you the vertex and it gives you a point, and this point's not a y-intercept. So same thing's gonna do the same process. You're gonna put it into the same thing. You just don't know which way it opens. So you can kind of figure it out actually from the vertex of the point if you need be. And the other point is not a y-intercept, so the x is not a 0. So that makes it a little bit tougher. So try it out. Kind of the same thing. It's a little change up. So we're gonna do what f of x. Well, let's leave our points first. H is gonna be 1. K is gonna be -2. And it gives us a point x, 2, and f of x or y is 1. So those are the values that we're given. We can figure out if it's open and up or down. If you notice that h is 1, if you have an x value of 1, and then the other x value is 2, should be open or up, it looks like. But we'll see how it goes. So if you don't catch that, it's not a big deal. But I would say probably A is going to be positive. We'll see what happens. So we're going to plug that in to f of x is equal to a times x minus h squared plus k. And so we're going to plug everything in to solve for a. 1 is equal to a times 2 minus 1 squared plus a -2. Make sure I put everything in the right place there. I think so. All right, so we're going to have 1 is equal to a, and 2 minus 1 is 1 minus 2. That's not bad. So it's going to be 1 is equal to a minus 2. Let's add a 2, and I get 3 is equal to a. This is not the best, but at least it's not negative. So I know my a is equal to 3. That tells me that it opens up. We didn't know before. And now we just got to plug in the h, the k, and the a. Leave out the x and the y. And so we're going to have f of x is equal to 3 times x minus 1 squared minus 2. There may be one homework problem, I think, where they ask you to put it in like that and not get in at ax squared plus bx plus c. It's just kind of an intermediate problem to get started on it, but just so nobody gets frustrated with that. So we have f of x is equal to 3 times, when we expand that, it's going to be x squared minus 2x plus 1, and minus 2. Now we're going to distribute the 3 to every term in the parentheses there. We're going to have 3x squared minus 6x plus 3 minus 2. And so we're going to end up with f of x is equal to 3x squared minus 6x plus 1. They don't give us the y-intercept, so don't really know. But it looks like you have a y-intercept of 0, 1, which is interesting because the other point is 2, 1. But that's fine. Remember, 2x values can be mapped to the same y value. Just can't go the other way. Any questions on that problem? No. So the main thing, like I said, make sure you plug everything in the correct spot. Make sure you distribute and expand that square term correctly. I think those are the biggest mistakes that happen. Other than people just not knowing how to work the problem whatsoever. They're just small mistakes. That's usually what it is. All right. So let's see how we can use this in an applied situation. So if you have something that can be modeled, remember we talked about linear modeling. What if something can be modeled with quadratic function? So an accepted relationship between stopping distance z in feet, so d is our distance, and a car, and the speed of a car v in miles per hour, so it's v, we're probably talking about velocity, that's why I use v, is d of v is equal to 1.1 v plus 0.06 v squared. And that's in good conditions on dry level concrete. Now I would rewrite that as 0.06 v squared plus 1.1 v, right? Because we usually want ax squared plus bx plus c. So av squared plus bv plus c. C is 0 in this case. And so we want to know how many feet will it take a car traveling 50 miles per hour to stop in that situation, well, that means we're going to do d of 50 is 0.06 times 50 squared plus 1.1 times 50. And bar so 0.06 times 50 squared is what? 2,500? All right, I think so. Plus 1.1 times 50. And I got 205. And what unit is that in? That's in 205 feet. I guess we could abbreviate feet. Any questions on that? So we're just plugging it in. And so let's say you perform an experiment to see if that works out. Yeah, it does. So hey, we're good with our function. We're happy with it. And what we're trying to figure out is part B. If an accident occurs 200 feet ahead, what is the maximum speed at which one can travel to avoid being involved in the accident? So basically, an accident happens 200 feet in front of you. What's the maximum speed you'd be going so that way you can hit the brakes and stop before you travel 200 feet? And so what we're going to do is say, well, we want to figure out what V is when D is 200. So we do 200 to 0.06 V squared plus 1.1 V. Now, you can work this out with the decimals, or we could also multiply both sides of the equation by 100 and get rid of the decimal. Let's go ahead and do that. Let's do that. So we're gonna multiply both sides of this by 100. As long as we do it for both sides of the equation, right? Should retain that relationship between each other. So we'll have now 20,000 is equal to 6 V squared plus 110. And if we want to solve this, it looks like we're going to have to factor, but I don't want to factor till it's equal to 0, right? So let's move that 20,000 by subtracting it from both sides. Did I just click? Oh, here's my calendar for everybody. Oh, there we go. Not sure what I did to do there. So what we're going to have is 0 is equal to 6V squared plus 110V minus 20,000. You could try to factor this, but man, I don't want to try to figure out the factors of 120,000. But you can. But what I would suggest doing, hey, let's use the quadratic formula. So in this case, it's going to be B is equal to negative B plus or minus the square root B squared minus 4AC all over 2A. And let's do the discriminant first. So we're going to have 110 squared minus 4 times 6 times 20,000. And we're dealing with some large numbers, but it's better than dealing with decimals, I would say. But either way, it works out. 110 squared is going to be 121,000. Oh, 12,100 minus 4 times 6 times 20,000, which is going to be 480,000. Did I miss a negative? Oh, This was negative. Sorry about that. I was going to say, I'm pretty sure this has a solution. There's negative 20,000. So it's going to be plus 480,000. Any questions so far? No. So let's add those up. And we get 492,100. So it looks like we will have two solutions to this, which is odd. How will we get two speeds? Let's continue and see what happens. So we know we got to keep going. So b is equal to negative b, so negative 110 plus or minus the square root. Keeps kicking out. Plus or minus the square root of 492,100, which is what? 492,100 over 2 times 6. The big question is, can we take the square root of that? I don't recognize it, but it looks like a. Nope. Does not work out perfectly. Let me make sure I typed it in correctly. Yes. I'll do it twice just to make sure. 492. So, since we're not looking for an exact answer, we want to find out the speed. We don't want to tell whoever we're talking to, like, oh, it needs to be a 5 plus or minus the square root of 7. No, we're just going to plug this into our calculator. So we're going to end up with negative 110 plus or minus. And when I did that square root, I got 701.49. Let's assume we want to do just 701 over 12. And so this is going to give us two solutions. And I guess this is approximate at this point. But we'll have that the velocity could be what? We take negative 110 plus 701 and divide it by 12. I get about 49.25. And if I do it the other way, it was negative 110 minus 701 divided by 12. I get negative 67.58. You can also do this as one, put this in your calculator here to be more accurate if you wanted to. Negative 110 plus the square root, of 492,100. I'm just curious of how accurate our answer was. Divided by 12. 49.2, you get 49.29. And the other one you get 67.62. So we're off by a few decimals. But which one of these answers makes sense? Do they both make sense? What do you think? We're trying to figure out what is the maximum speed you could be driving at so you can stop at 200 feet. The 49.25, right? It doesn't really make sense for me to be negative 67.58. It's like I'm going in reverse. Negative 67 miles per hour. So 49.25. So our answer would be, give me a marker. 49.25 miles per hour. And there you go. So in a real world scenario, when you're doing this, you'll get two solutions most of the time, unless the vertex is the one. Or you'll get no solution. But usually in a real world scenario, there's one solution that has to get thrown away because it doesn't make sense in the context of the problem.